Now let's get the nature of the human foot and its footprint in order to see if we really have human footprints. Every once in a while, one of these articles will come out with a statement, Ball and his team have excavated quite a few tracks with ephemeral markings. What's an ephemeral marking? Nebulous, you can't really draw a conclusion on it. It's just a bunch of markings, bunch of depressions. You don't really know what it's about, ephemeral marking. So really, have what we have excavated demonstrated ephemeral markings? The nature of the human foot and its footprint in order to see if these prints we're discovering are human footprints. In order to determine whether there are genuine human fossil footprints among dinosaur footprints and elsewhere in the geologic history of the rocks, we should examine certain details regarding the structure and forward motion of the human foot. And we're calling on Dr. Aaron Judkins. Now, his doctorate is in archaeology, but he has a master's degree in medical science and is qualified to publish these statements, which he did. The special nature of the human foot and consequently the unique characteristics of its footprint are emphasized by medical author Aaron Judkins. He's present in this audience today. The human foot is a postural structure, he states, meaning it cannot undergo any change that would not affect every part of the body that relates to posture at the same time. Feet are unique. If you don't believe me, just damage your feet. They hurt all the way. The posture of the foot is related to the rest of the body, and the rest of the body is related to the posture of the foot as well. The ankle serves as foundation, shock absorber, and propulsion. And the human foot is unique. The foot can sustain enormous pressure and provides flexibility and resiliency. Still quoting. Structurally, the forefoot bears half the body's weight and balances pressure on the ball of the foot. The midfoot has 5 irregularly shaped tarsal bones, forms the foot's arch, and serves as a shock absorber. The bones of the midfoot are connected to the forefoot, but these bones are all connected intricately and intimately. And the hindfoot by muscles and the plantar fascia, arch ligament. These components work together to provide the body with support, balance, and mobility. This was included simply to let you know that the entire structure is intimately related. And Aaron continues to write, bipedalism is a characteristic only of human beings. And while, as Professor Hefner stated earlier this week in the series of lectures, dogs can temporarily walk upright, bears can temporarily walk upright, monkeys can temporarily walk upright. There are certain monkeys that have a little more dexterity to do that, but no monkey habitually, or no lower primate habitually walks upright. A human's hips, pelvis, backbone, in fact, all parts of his skeleton are designed for bipedalism. The placement of the large toe in humans is unique. In ponghids, the monkey kind, such as the gorilla, the big toe is positioned so that it can be used in climbing and grasping. The big toe is used in a manner similar to the thumb, our thumb. In animals, the big toe is parallel with the other toes, important for what in humans, the big toe is parallel with other toes, important for walking bipedally. The human heel is 4 times the size of a gorilla heel and twice that of a chimpanzee. This is because it contains a lot of spongy bone that absorbs the shock of walking. Good for our team. One leading anthropologist came down after I went on television and described and showed pictures of what we'd found, but they waited 6 months. They knew the nature of carbonic acid. And we'd excavated a trail of 23 dinosaur footprints. The last 4 of them were stepping on and near a trail of 4 human footprints, 16.5 inches in length. Watch this. So from one of the nation's leading universities, a lady, no, a woman, came and she started measuring. She measured the 16.5-inch footprint. She had calipers, did a good job measuring that. Then she measured where the dinosaur had stepped into 2/3 of the human track. It had the toes and everything, but the back was obliterated by it. I mean, if a dinosaur steps on your track, it's gone. So she measured the front portion of the human print. It was 4 inches. And then the next track, the dinosaur missed the track, but in his forward locomotion, he compressed it. The heel was there, everything was there. 2 were perfect at each end, but in the 2 middle ones, the heel was there, everything, but it was compressed into a lump. That measured about 6 inches. So she went back and in a technical journal, published. I've examined Ball's trail of tracks, so-called human tracks. They change sizes and shapes with every pace. One 16.5 inches. The next is 4 inches. Then the next is 6 inches. I have no idea why he could claim that to be a trail of human prints. Is that honest journalism? No. That's selective data, ignoring all the compilation of data. But that's what we're dealing with. So really this issue, it's more important than I can emphasize. The degree to which individuals go to disclaim it or support it. So I think we need to know a little bit about the human foot in order to know if it's a genuine human footprint. In order to determine whether there are genuine human fossil footprints among dinosaur footprints and elsewhere in the geologic history of the rocks, in order to do that, we should examine certain details regarding the structure and forward motion of the human foot.